Alright, so in this video we're going to be solving the following problem. So we are given two strings, S1 and S2, and we want to write some code to check whether or not S2 is a rotation of S1. So an example of a rotation is given in the line below, where we have the word water bottle, and a rotation of that word is this string right here. So basically all that's happened is we've just jumbled up the letters in the word water bottle to arrive at this thing that's not a word, but it consists of all of the same letters. So there's an example of a valid rotation with these two strings. That's the example from above. And then there is a example here of these two strings where this is not a valid rotation, as there's no way to rotate these letters here to arrive at this one here and vice versa. So what we're going to do is we're going to write a function to determine if one string is a rotation of another. So the first thing that we can do is we can make an observation, and that observation is that if the length of the strings is different, then there's no way we can rotate one string to arrive at another. So in these examples here, both of this pair of strings here and this pair of strings here are the same length. But you can imagine a pair of strings where one has a different length than the other. And if that's the case, we can't, a rotation does not involve adding in characters. So one immediate disqualification that we can put in here is to check if the length of string 1 is not equal to the length of string 2. So if this if statement is valid, we can just return false because we know that the rotation will not be a valid string rotation. Okay, the next thing is I'm just going to do a little bit of pre-processing on the strings that we're getting as input. So again, this property is not reflected in this example here, but we can imagine that we might get a pair of strings that have a mix of upper and lowercase letters in them. So one thing that we can do is we can just make sure that everything is lowercase. So what I'm going to do is I'm just going to set string 1 is equal to string 1 dot lower, and I'm going to do the same thing with string 2. So that all that does is if there are any uppercase characters in the strings that we're given, it just converts it all to lowercase. So the next step that I want to do is I want to solve this problem using a hash table. So again, there's a number of different ways to solve this particular problem. This is just one of many, and it's one that involves the use of a hash table. So if you want, go ahead and pause this video, try it for yourself, try it with using a hash table in mind, see if you can get a solution yourself. If you're stuck or if you want to see how I solved it, feel free to unpause the video and follow along. So assuming that you did that, what I'm going to do now is I'm going to define two dictionaries equivalently to hash tables. Dictionary is Python's word for hash table. And these hash tables are going to consist of the letters of the alphabet and a corresponding value that corresponds to the count, the number of times that we've seen this letter in either of the strings. So let me write out something and then I'll describe exactly what the line means. So I'm going to say dictionary 1 is equal to this thing here, and I'm going to explain this after I write it. Alright, so this is defining one hash table, and we're also going to define another hash table, which we'll call dictionary 2. So what is happening here? Let me actually call this function to make that line a little bit more concrete. If you haven't seen this type of syntax before in Python, what I'm writing out there might not be entirely clear. So let me actually call a few things individually so that way it's clear what I'm doing. So in this line here 20, what I'm doing is I'm creating a dictionary. So I'm saying create me a dictionary where the keys of that dictionary consist of this thing, where this is a list of all of the alphabetic characters. So for instance, if I print out list of string.ascii lowercase, this is going to give me all of the letters of the alphabet. So it just returns me, well, this thing here is a string that corresponds to all of the letters of the alphabet, and this converts that to a list. So these end up being the keys of our dictionary. By the way, this string.lowercase ASCII lowercase is part of the string library in Python, which I've imported above here. If you didn't notice, I didn't mention that, so apologies about that. Anyway, so I'm creating a dictionary where these are the keys, and then I'm placing in the corresponding values for each of the letters to be 0. This is going to be the count, the number of times we've encountered a certain letter in the string. And there's a separate hash table here for the second string. So if I print out dictionary 1, what I'm going to see here is a dictionary consisting of the keys being the letters and the corresponding values being initialized to 0. So what we're going to do now is we're just going to loop through the strings, and we're going to keep track of the count, essentially the number of times we've encountered a specific character in the string. So what I'm going to do is I'm going to say for I in range length of string 1. So the reason I'm doing string 1 instead of string 2 is just basically for convenience. We know at this point that the length of string 1 and string 2 must be the same, otherwise we would have exited the function at this point up here. So by the time we hit the loop over here, we know that the length of string 1 and string 2 are equivalent. So whether or not we loop through either string 1 or string 2 is totally up to you. And so what we're going to do in this loop is we're going to keep track of the count of the letters that we see in the string. So what I'm going to do is I'm going to say dictionary 1 of string 1 of I plus equal 1, and I'm going to do the same thing for the second dictionary as well. So what I'm doing here is I'm looping through the string, and anytime I encounter a letter in the string, I'm consulting the entry of that dictionary for that letter. I'm saying, okay, I encountered this in the first string. Please increment the value of that corresponding letter. So for instance, for this water bottle string up here, we start the loop that starts at line 23. We look at the first letter, which is W, and essentially what happens here is we say, okay, consult the first hash table and look at W, the entry W, and increase that value by 1. So we just loop through the string, and at the end of the day we have a histogram or a dictionary that corresponds to the frequency of the letters in string 1 and string 2. So all we really need to do at the end of the day is we just need to return whether or not the dictionaries are equal to each other. Because if they are equal to each other, then there's a valid way to rotate one string into another, and if they're not, there's no way for us to make this rotation valid. So what we can do is we can print a call to the first set of test strings. So this should return true, since these strings are valid rotations. And let's do the one on something we know is not a valid rotation, which is on strings 3 and 4. So this one should return false, since these strings are not valid rotations. So if we run this, we get true for the water bottle and rotated version of water bottle, and we get false for this pair of strings here. So that's it for this video. Thanks again for watching, and have a great day.